looking at the question is when, or what the depth is when t equals 30. We substitute 30 for t. We obtain this equation. Gives us y equals 62.98. The model gave us, zoom in a little bit here. The model told us that when t was 22, the depth was 70. When t was 34, the depth was 60. Our calculation here, I'm sorry, this is not the model, this was our data, told us 22, 70, and 34, 60. Our model tells us that at time 30, clock time 30, the depth is 63. Does this make sense? Well, 63 lies between 60 and 70. 30 lies between 34 and 22. 63 is closer to 60 than it is to 70. 30 is closer to 34 than it is to 22. And the proportionalities involved here are pretty close. This would lead us to believe that this model has done a pretty good job of predicting the depth at the clock time 30. If we move back to the question of when is the depth 42, we see that we obtain the equation 42 equals 0.00230 t squared minus 0.903 t plus 88, the equation that results from the model. And we can solve this as a quadratic equation again. We don't want to mess around trying to get all the t's on one side and all the numbers on the other, because it just isn't going to work since we have a t squared and a t. We'd have to resort to black magic or something worse in order to solve it by those methods. We solve it as a quadratic equation, subtracting 42 from both sides and getting an at squared plus bt plus c equal to 0. And then we simply follow the procedures for solving a quadratic equation. We substitute into the quadratic formula and evaluate our numbers.